Let's see what we've got here. All right, we've got 4 people. Just wait for a few more to turn up. If somebody could please just put a comment in the chat, just so letting me know that you can hear and see me okay, be great. Thank you. So we'll just give it a minute or two. While we're waiting, I'll show you just these. I'm going to show you this at the end as well if I have time, but this is just a bus bar I've had made up for Helios batteries. And so you have a pair of these and you have 3 125 amp CBI breakers. You put 3 Helios together, because normally you won't need more than 125. You won't even need that per battery if you're using up to a 10 kilowatt inverter. And that allows you to mount 3 on a DIN rail and have 2 of these bus bars and then go off from the sides to your inverter. But I've got a whole box made up with that. I'll show you at the end if I have time. Let's see how many people we got. All right, okay, I think we'll get started. So I'm going to try my best not to make this too much of death by PowerPoint, but I'll have to do it. I have to have some slides. So let's just get our slides up. So we're talking about the Helios battery and how you're going to commission that with Selectronic, Deye or Victron batteries. So just to go over the Helios for those of you who aren't familiar with it, it's a 48 volt battery, 16 kilowatt hours. It's IP65 rated, so it can go indoor and outdoor. It's rated at 200 amps, continuous charge and discharge. I think I wouldn't recommend you run it at that spec. I wouldn't recommend you run anything at the top spec. Peak power 26 kilowatts for 10 seconds. You can have up to 36 modules in parallel, and that's with closed loop communication. So you could have more than that, but it will have 36 on the comms network, and that's just a sort of RS405 limitation. So that's a half a megawatt. That's a pretty big system. It's got a 10-year warranty. Make sure when you install these, there's a big sticker on the front now saying to register the batteries, because to get the full 10-year warranty, you've got to register the batteries. Indoor and outdoor rated. It has self-heating, which is not much. They're a Canadian company, so it's not much of an issue here in Australia, maybe in some parts of Tassie, but even then, the ambient temperature might get low, but the battery is unlikely to get down that low. But it will heat the battery if it needs to. And it also has fire arresters built in, 2 fire arresters just below the BMS above the cells, which is really cool. It's on the CEC list. Originally, it was on the CEC list without outdoor rating due to a sticker issue, but now that's all sorted. Oh, I should have changed my slide. So it is on the CEC list for outdoor use now. There's the sticker. I'm sure most of you are probably aware of the rebate issues for on and off grid, but it's suitable for on and off grid for getting the battery rebate. It's compatible with a range of inverters, but it's the ones we're going to talk about chiefly today are Selectronic, Victron, and Deye. It's being used with a Solus as well, and basically, most of these battery manufacturers, they all use the same CAN bus protocol, and that's basically the Pylon Tech protocol, or they call it the Pylon protocol. And so anything that's sort of compatible with Pylon Tech any other battery that's using that protocol is compatible, depending on how you look at it. So by that, I mean it will talk to the inverter, and the inverter will understand the information that it's getting from it. But in terms of a tested, verified integration, that's Victron, Selectronic, Deye, and Solus are the ones that are really well supported by Discover. I think there's some others, again, on their website, but they're not ones that are common in the Australian market, and certainly not ones that we sell. In terms of the physical installation, obviously all the normal requirements of the standards are going to apply. The dimensions are 900 mil high, and it's 465 wide, and it's about 250 deep. It comes with a bracket that you have to sort of lift it up onto, because originally it's thought of as a wall mount battery, like a Tesla Powerwall or something like that. But you don't have to mount it that way. And they are going to be bringing out in the near future a different bracket that allows you to just slide it up and fasten it without having to lift the battery on. There are handles that we have in stock that you can buy that allow one person on each side to lift the battery up onto the bracket if you want to do that. But yeah, it's fine to just sit on its own feet. It just needs to be anchored to the wall to stop it from falling over. Again, these are just the normal specs here. Here are the connections on the left and the right. I need to update my slide actually, because they've removed the screen now, and this button on the right hand side here is now on, well, the button that was on the left is now on the right hand side in the left of my picture. So on one side you've just got the negative terminals, and then on the other side you've got the positive terminals, you've got the breaker, and you've got the COM ports. And so these are all Amphenol connections, well, Amphenol style. And then the breaker is a single pole breaker. So you do need, to meet the best practice guide, you do need a 2-pole breaker after the battery. It doesn't need to be 200 amps. If you're using a single battery, you'd probably use a 200 amp breaker. Obviously anything larger than that is pointless, because the built-in breaker is 200 amps. If you're just using the one battery, 200 amps, depending on the size of your inverter. But if you're using multiple inverters, then you might not need such a large breaker on each battery, because you've got the combined current of all the different batteries. These comms cables, and I'll go into more detail in a moment, but you've got COM 1, 2, 3, and 4. So COM 1 is a USB port, and that's for plugging a USB-C cable into your laptop. A really easy mistake to make is that, and I wish I had the physical thing here to show you, is that you have the USB port, and then it has like a circle around it, and then it has that's the sort of the plastic molding, and then around the outside of that there's like a metal housing, and the gap between the plastic molding and the metal housing is about the same width as a USB-C port, even though the port itself is in the middle of the plastic. And so if you're plugging the USB-C cable in and you're not looking at what you're doing because it's sort of down on the side there, it's really easy to plug it into that gap around the outside of the molding instead of into the USB plug. And I've spent ages wondering why it's not working, and realizing afterwards that I wasn't looking what I was doing. And I've had other people complain about the same thing, who I suspect were doing the same thing that I was as well. So that's just an easy gotcha. COM number 2, this is the CAN bus output, and that goes directly to your inverter. And then COMs 3 and 4 are for linking the batteries together for their comms. And you need to have an N terminator in one of those. So if you just have one battery, you just put the N terminator into COM 3 or 4. If you were to have 2 batteries, then you would link them together with COM 3 or 4, and then just have an N terminator in one of the empty slots. We'll cover that again when we get to the more detailed commissioning. And then you have the power on button as well. The screen is not there anymore. This is the bracket I was telling you about. So you lift the battery up onto this bracket, but it's really there unless you're lifting it above the height of the feet. It's really there just to stop it from falling over. So it's a CAN bus battery. So I would highly recommend that you used the CAN bus comms protocols and do these closed loop for any installation you're doing. It's a big advantage, but you can do them open loop if you want to for some reason. And I also recommend that you set the open loop settings, especially on Victron, anyway, as a fallback. So we'll go through those. Obviously, what open loop means is that you don't have any comms between the battery and the inverter. The inverter is just going to read the voltage and current going in and out of itself, and it's making all the decisions about when to charge and discharge the battery. The battery has no control over that. So for Victron, you're going to set up the settings in VE configure for the inverter and in Victron Connect for the MPPT. You can use Victron Connect for the inverter as well if you like, but I usually prefer to use VE configure. For the inverter, you're going to need one of these. So this is an MK3 dongle. So whenever you're setting up a Victron inverter, you're going to need one of these. You don't need to leave this on site. This is just for the installer to have. So if you're new to doing Victron, you need to buy one of these with your first order. It's not particularly expensive, and this just plugs in USB, it plugs into your laptop and allows you to set up the inverters. You'll need to download the software from the Victron website, and there's just one link for that, and that will include Victron Connect and VE configure along with some other tools. And you're going to go to the Discover website and have a look at the manual, and let's just have a look at that have a look at that now. So in the manual, it's going to give you these charging voltages. It gives you a range, but if you go down into it, it will give you specific recommendations for Victron. We'll go back to our slides here. And so you bring up those values, and then you're going to put them in. So for the MPPT, and actually I'll walk you through this because this is pretty important. So I'll share my screen. Share entire screen. Okay. So we're in Victron. I'm going to use the demo library, but you're going to connect either over Bluetooth or with a V-Direct cable of some kind. Let's find a nice big charger. Doesn't really matter which one of these. And so we're going to go in here. We're going to go to the cog in the top right-hand corner. We're going to go battery. And what's quite important with Victron MPPTs is that, and you can't change it on here, but if you're using something like the 250-100, you should set the battery voltage before you apply any PV. So when you first fire up, you've wired up your system. When you want to first engage with the MPPT and put power to it, don't turn on the PV, turn on the battery first. And then it's going to detect that it's a 48-volt system, and also it's going to boot up and allow you to log into it and make these changes in the settings. If you do it the other way around, there's a bit of a problem because if you turn on the PV and don't turn on the battery, for instance, it's going to fire up and you're going to be able to change the settings. But unless you put it onto 48 volts before you turn the battery on, it could still be on 12 volts, for instance. And in which case, when you turn the battery on, it's going to see 48 volts and it's going to think, oh no, these batteries are way overcharged, and it's going to short the PV input terminals to prevent it from overcharging the batteries. And then you're going to have to go through a long process to undo that, which it can be done with the 250-100s. So batteries on first, do your settings, and then you can turn your PV on when you're ready. So we're in our settings here. Battery voltage on this particular model is not adjustable. We've got max charge current. You can dial that down if you want to, but usually it's set default at the default output. So obviously 100 amps is fine for a Helios battery, just as long as the inverter that you're using isn't going to put out more than 100 amps as well. And it's not going to be more than the total of what the battery can handle. Charger enabled, of course, and battery preset. So the way I like to do this is I go in and I go to select a preset, and I go down to Smart Lithium, and I go OK. But I don't leave it on there. I just use it to set up the template. And then I'll go and change my absorption voltages to what is recommended in the Helios manual, 55.2. And we'll just check what they've got for the other value. Be sure it is 53.6. Let's just check. Yes, 53.6. And that's pretty much all you need to do. There are some extra settings through an expert mode, but you're not normally going to need those. And so this process here, most of you guys are going to be using closed loop communication, but you should set this up anyway. If the battery loses comms to the Cerbo, it's then going to stop allowing the MPPT to charge, and it's going to say BMS lost or something like that on the MPPT. But what can happen is if the system goes completely down and then boots back up again, then the MPPT will just restart in its normal mode and start charging the batteries. So you should have all the stuff set anyway. And then we have the same in VE configure. So in VE configure, what we're mostly interested in is our charge voltages here. So we're going to set those to 55.2 and 53.6. And these values are lower than what it will ask for when it's charging in closed loop communications, because it has to be more conservative when it's not talking to the inverter. The specs are in the manual, but it's 1 hour repeated absorption time, 7 days interval, and 1 hour for this as well. And you want it on lithium batteries as well. You also need to set the low voltage disconnection values. And those are here. So 48, shut down, restart at 52, and the alarm 49.5. So these are just set here. And then the rest of these settings are going to depend on what you're doing with your system. Any questions about that before I go on? Emma, output current is adjustable in expert mode. I think that's adjustable in the normal part, isn't it? Max charge current is the output current. And yeah, so any questions about that? Doesn't look like it. So it's pretty straightforward doing it in open loop. The same is going to be true for Noark as well. So Noark and Deye, you're going to go and put the battery onto battery voltage. So this is in the battery settings on the Deye, and then you're going to set up, you're going to tell it it's 200 amp hours if it's a single Helios. And then you're going to go and set these float and absorption values as if it's a lead acid battery. It's important to have activate battery and disable float charge switched on. And then the Selectronic, I will cover that when I do the Selectronic section because that's a little bit different. So for closed loop communications are that the battery is talking to the inverter, and it's basically sending it information about the battery, and it's sending it a target voltage and a target current. It's also sending it the state of charge, the terminal voltage, the state of health, but its main job is to send that target voltage and that target current, charge current and discharge current, so it can effectively tell it when to turn off its charging or its discharging. These values are dynamic, so it's different to just setting it on the inverter, and it means that it can charge it at a higher rate when conditions are favorable, and then roll that back if the battery's hot or if it's getting towards the top of the charge cycle or towards the bottom of the charge cycle. If you don't have that those dynamic communication, then you have to be more conservative with those settings. There's a question here, did you say disable float charge on the Deye? Yes, it wasn't on my slide, but yeah, they recommend that you disable the float charge. So we went over this before as well. The CAN bus output is on COM2, which is number 14 here. And so there's two different, it can be a bit confusing with closed loop communication with Discover products. So the original rack mount batteries, if you're familiar with those, did not have CAN bus output on them. They connected to the Link 2 device, one of these, and the Link 2 had the CAN bus output. The Helios batteries have CAN bus built into them, so you don't need a Link 2 at all. You can just go out of COM2 straight to the inverter. To make things complicated, you can also use a Link 2 if you want to, and you could use the CAN bus out of that instead of the CAN bus out of the batteries. There's no real advantage to doing that. It's just a different way of doing things. And I'm not going to cover setting that up because I think it will be too confusing. So I'm just going to assume you're going to use the built-in CAN bus. The reason you might use one of these, even though you don't need one for the CAN bus, is it gives you access to Link Cloud, which is the online monitoring platform. And I'll cover that at the end. It's a good idea to use the Link Cloud if you've got more than one Helios battery. I don't particularly recommend it if you've only got one Helios, because you're not going to get much more information on the cloud than you're going to get through, say, the Deye or the Victron cloud, because that's showing you all of the batteries' stats on their cloud anyway. But once you get more than one battery, you only get the combined stats instead of the individual stats for each battery, which is what you get on Link Cloud. So I do have a little video on how to set up the Link 2, but I think we probably won't use that because it's going to make things more complicated. when you look in the manuals, it's going to talk about taking this apart and setting the dip switches on it. So the way that these work is that they have an RJ45 plug with a CAN bus output on it. And the standard pinout for CAN bus is 4 and 5. And that's what Deye uses. That's what Solus uses, I think. Most manufacturers use that, and that's what Discover uses for their, as the default for their CAN bus output. Pylon-Tech uses it as well. For some reason, a few manufacturers like Victron and Selectronic have their CAN bus pins on different pins of the RJ45, even though they don't use the other pins for anything else. So Victron's 7 and 8, and Selectronic is pins 1 and 2. The best way to deal with that is to just use a crossover cable that takes the pins, is 4 and 5 on one end and is 1 and 2 on the other end, for instance, for Selectronic. The Selectronic comes with that cable when you buy it. Victron, you'll need to buy a Type A cable. If you don't want to do that, then you could use a normal Cat5 cable, and then you'd adjust the pinouts in here. But what you definitely don't want to do is buy the crossover cable and adjust the pins, because then you'll have undone the work that you've done. So I'd recommend forgetting about the pins and just using the CAN bus output on the battery and using that crossover cable. So if it's straight from, if you're doing Deye, straight from the battery to the inverter, just a normal cable is fine. Same for Noark. If you're using Selectronic, you use the cable that comes with the Selectronic. And if you're using Victron, you need a Type A cable. Now, there's a bit of setting up of the battery to do. You're going to plug into it with a USB-C cable. The current batch doesn't come with a USB-C cable. I've been asking them to include one. Hopefully they will do in the future. So you're going to plug into that USB-C cable we spoke about before, plug into your laptop. You need to download link access, and you're going to see this screen here. It's a good idea when you download link access to see if there's an updated firmware for the battery. And if there is, you can update it here as well. You just press that blue button, and then it'll ask you to go and find the firmware that you've downloaded onto your computer. And then you click that and it will just update it. But what we're interested in here is this button down here, which is CAN settings. And so when you open up the CAN settings, you're going to have this menu here. I'm going to show you this in real time using the Link 2, which is going to look slightly different, but it will be good enough. So you're going to press that CAN bus button I showed you before, which is the equivalent on the Link 2 as this button here. And that's going to give you options. And the two options that will be available will be LV BMS. They'll all be LV BMS, but it will have two options, which are dynamic voltage and dynamic current. What this means is that it can manipulate the inverter's charge rate by changing either the voltage request or the current request. So if you think about Ohm's law, for a fixed amount of resistance, the voltage and the current are going to be, if you reduce one, you're going to reduce the other. So if you drop the current, the voltage request, then the current is going to have to go down as well. So these are different styles of controlling the inverter, and they seem to work better or worse with different inverter manufacturers. So dynamic voltage is what I recommend for Victron, and dynamic current is what I recommend for Deye and for Selectronic. At the moment, I wouldn't bother playing with these settings below here. The standard ones are fine. The only other thing to take into account is the baud rate. So it might be fixed on the Helios perhaps, but if you do have the option, it's 500 for both Selectronic and Deye or Noark, and for Victron it can be either 500 or 250, but I'd recommend you just keep it on 500, but you do have the option. When you set it up on the Cerbo, when you set up your CAN bus settings, you'll need to set that baud rate as well. So Selectronic would stop charging at 90%? No, it just means it's going to start curtailing it at that set point. It's not going to stop charging it at 90%. Yeah, it's just, that's the point that it's going to start its ramp down. So I think they probably shouldn't have those settings in there for now because it leads to confusion. You should just leave them as they are. It's just to do with the style of how they, because they're doing their own constant current, constant voltage algorithm as well. And this is just manipulating that so that it doesn't overshoot, basically. So if you're using Deye or Noark, then you are going to come out of COM2 and into the inverter. If you're doing it with a link 2, then you don't need a terminator plug because the link 2 acts as a terminator, and that's going to be connected to COM 3 or 4. If you're doing it without a link 2, then you're going to put a terminator in COM 3 or 4. And you can see this is where the CAN bus port is. This will be different on each inverter, but in the manual it will show you where that is. It's always an RJ45 plug, and if you're, and this is more for the meters actually for Deye/Noark, but the appendix is all the way at the bottom of the manual. The last couple of pages has all the pinouts for the RJ45 plugs, but that's usually an issue for the meters. You won't need pinouts for the CAN bus, but some of them specify a ground and some of them don't. And I don't think it's ever an issue not having the ground for the CAN bus, but on some inverters, they share the RS485 and the CAN bus on the same RJ45 plug, and the only ground available is the ground for the RS485. And if you put the CAN bus ground onto there, that can sometimes cause some problems. So I'd recommend not connecting the ground for Deye and Noark most of the time. Yeah, so this is a good example of that. You can see that we've got CAN high on 4, CAN low on 5, and then the ground, which is 6 or 3, they're all for the RS485. And it doesn't seem to always be a problem, but I have seen it be a problem for somebody once. It wasn't working, and then once they removed that, it all came shipshape. So when we're setting up our settings for closed loop with Deye, we're going to go into the battery settings and we're going to click on lithium. You can set the battery capacity here, but it doesn't really matter because it's getting the information from the state of charge information from the battery. Set your charge current. Obviously, a lot of the time it's going to be lower than the maximum the battery can handle anyway, depending on what size inverter you're using. And you shouldn't really have a larger an inverter that's capable of putting more than that in, because usually that would be a bad design, but might be some scenarios when you do that. But obviously adjust that according to how many batteries you've got, if that's the case. We want to have activate battery ticked, and we want to have disable float charge ticked. And then you're going to see this on page 3, and it's going to say lithium mode. You can't change that. And then you're going to set your shutdown, low battery and restart values here. I would recommend that you set these quite conservatively. I know that battery manufacturers advertise 100% depth of discharge for their batteries. And there can be a bit of confusion about that because some manufacturers might have a battery which is 5 kilowatt hours, but they advertise it as 4.5 or something like that. And so then you can use 100% of it. I don't think there's many of them doing that anymore. And it's true that you can take 100% out of the battery, but that's just a function of the cells. It's not a function of the rest of the system. So the analogy I like to use is you can take 100% of the petrol out of the tank of your car and you won't break the tank, but you're still going to run out of petrol and have to walk to the service station, and it's still probably not very good for the engine. And it's still a bad idea. So whilst it might say 100% usable, that's just the battery. It's not the entire system. So don't set your shutdown to 2% or something like that. 10% as a minimum, but I would probably have it more like 15. And then the low bat is just the alarm when it's going to start complaining about it. And then you restart. We've got 40% here. Maybe you'd even have it higher because once it's switched off, it's, you know, the inconvenience has already happened. So you may as well let it all come up and be nice and healthy before anything else happens. These are the open loop settings. Not sure why they're there, sorry. Now the other, and this is more of a day commissioning thing, is that on the advanced function menu, we've got two really important values here. DRM comes default switched on. You want to switch that off unless you're in Queensland and you're doing DRM, and you should know about it if you are. Otherwise, you switch that off, the inverter won't work if you don't have it switched off. And then BMS error stop. If you're doing closed loop communications, you need to have that on. What that means is that when it loses communications, it will stop instead of just continuing with whatever the previous command was. I'm not quite sure why that isn't even an option, but it is. So that's it for day. How are we going for time? Okay, there's just a message from Emma here. I'll just check that. Electronic systems are potentially unstable in off-grid situations. Fully charged lithium batteries, as they use impedance for stability. 100% state of charge batteries, essentially open circuit. What is the situation with electronic closed loop Helios batteries? How stable does the closed loop system charge to 100%? Well, I mean, 100% is a relative value. So what Em is asking about how stable the system is when the battery is 100% state of charge. And maybe this is a question to take offline, but the state of charge is determined by the manufacturer as a safe point to take the cells up to, right? So a lithium cell nominally is in trouble when it's 4.5 volts, right? And you'll see some specs saying 4.2 volts for like lithium cells by themselves. But no manufacturer of these types of batteries is taking their batteries anywhere near that. They're taking them up to sort of 3.6, 3.7 volts per cell. There's no magic thing within the cell to say what its state of charge is. It actually, the BMS is just doing the same as what, say, a Victron shunt is doing. It's just measuring the current in and the current out. And then it's also got an algorithm saying, well, once I reach this voltage for this amount of time, I'm going to say that I'm 100%. So there's not a, it's not a black or white thing, what 100% state of charge is. It's the manufacturer's, if you charged up higher, you'd probably get a little bit more capacity out of it, for instance. So if they set their charge voltage higher, they might be able to advertise the battery as being a bit larger. But the flip side of that is that probably would degrade quicker as well. So they tend to set these values lower, but it would be tiny amounts of extra capacity you'd get. So it's more about warranty stuff than it is about a real state of charge. So Helios commissioning with Victron. So like I've said, the pinout is different on Victron as to what you have on most other equipment. So the pinout on the Helios is pins 4 and 5, but the pinout on the Victron is pins 7 and 8. So you just want to buy the type A cable when you buy the system, and that translates it from one to the other. Make sure you get it the right way around. It says battery on one end, it says inverter on the other end, even though it's going to the Cerbo. And so on your Cerbo, it's going into one of your CAN bus ports. The Cerbo will come with some little end terminators. So you're going to put it into, say, this pair of CAN bus ports, and then you put the little blue terminator in the other one for stability. Don't put it into the VE bus ports, and don't put a end terminator into the VE bus ports either. That's just for the inverter, and the end terminator causes problems because it's just for CAN bus. Also, don't put it into the Ethernet port here. It's an easy mistake to make. Because if you do that, it will probably shut your inverter down. So here's a little diagram. So we're going from COM2 of the Helios into the CAN bus, and we've got our end terminator plugs. If you're using a link 2, then that goes into COM3 or 4 on the Helios. If you're not using a link 2, you're just going to use that terminator into COMs 3 or 4. If you're linking multiple batteries, you link them together with a normal RJ45 cable from COM3 to COM3 or COM3 to COM4, doesn't matter, and then have a terminator in one of them. The terminator comes in a little bag with the black cable that comes, the black RJ45 cable that comes with the battery. It's easy to lose it, so just be careful with that, but we now do have like 100 spares or something on the shelf. So if you do lose it, let us know, because it's difficult to make one yourself when you're on site. And so we'll go into Victron and have a look at our settings here. Most of this is going to be plug and play, in that you're going to plug it in and it's going to set itself up for the Victron settings. The things that you will need to set will be like the DVCC values, and I'll come back to that. But you want to have those fallback settings set. And then you want to set up the battery monitor as being the main battery monitor for that. So by that, I mean that the Helios is going to come up in the Victron menu as a battery, but then in the Victron settings, you're going to need to go and tell it that that is the master battery monitor, and to use that one for all the communications. Ricardo has a question. Is the Deye able to vary the charge current based on the CT grid export values in the case of multiple AC coupled solar, as the Deye thinks it's charging from the grid? Well, if you have AC coupled solar and no grid, they would need to be on the output of the inverter, because there will be no AC voltage on the input side of the inverter if the grid is down. It will vary the charge current according to values it's reading on the AC side, and it will throttle any AC coupled inverters with frequency in order to prevent itself from overcharging the batteries. I'm just not 100% sure I've understood your question properly. The CT grid export values. Or maybe you're asking if it's connected to the grid and you've got AC coupled on the grid side and it's looking at the grid export values. if you had it set to 0 export to CT, then it might see that extra charge and extra power available and charge the batteries with it. But I think the best thing to do is you can have a second meter and tell it that that's an AC coupled inverter and monitor it that way. And I think that would guarantee it to do that. Yeah, perhaps send us an email, Ricardo, and I'll double check on that, because sometimes the stuff can be a bit confusing. I want to make sure I've got that right. Often there's also a generator port on those inverters, which can be used for other things that they say as a smart port. And so you can put the AC coupled solar on there as well as another option. It just depends on how you're doing things. So yeah, send us an email and I'll work that out for you. Moving on to Selectronic. Again, it's the same picture. I'm sure you guys will get the gist. If you look at the managed batteries manual from Selectronic, it's got this really confusing diagram. I don't know why this is. Maybe somebody can explain it to me. But it's pins 4 and 5. Pin 4 goes to pin 1. Pin 5 goes to pin 2. And that's all you need. I don't know why it's got the reverse of that under here, but it does. Maybe that's because the cable they give you is wired that way for some reason. But all we're interested in is 4 and 5 going to 1 and 2. The cable that comes with Selectronic is all that you need for that. And that's just going to plug into COM2 of our Helios battery. And that's going to go into this slot down the bottom here. And there's flashing lights. There's 2 green flashing lights on the Selectronic, which will tell you whether or not it's talking to the CAN bus or not. I always can't remember if it's flashing means that it's talking or flashing means that it's not talking. But you can test it by pulling it in and out again. Once you've connected the CAN bus to it and it started reading it, it will then not operate unless, if you take it out again, unless you completely shut the system down and boot it up again. So again, like Victron, you want to set the off-grid settings for the Selectronic so that if it does completely go down and come back up again without comms, it's got the correct settings. But it's much easier in Selectronic because of the way that we're going to commission it. So yeah, CAN bus cable from there into there. It's reasonably straightforward. The way that we're going to do it to set it up for Selectronic is you're going to go through the site configuration wizard. The Helios is going to be in the wizard at some point, but at the moment, you just select the Discover rack mount battery. So you start up the wizard, give your site a name. I recommend you do the wizard when you're connected by USB to the Selectronic so that it has the correct inverter specifications. And then when you get to the battery drop-down menu, you're just going to select the Discover rack mount battery. The reason for that is because the BMS is the same. It actually has the same firmware. Jeff, my colleague in the tech department here, accidentally wrote the Helios firmware to one of the rack mount batteries, and we all thought that that was going to ruin it, but it didn't. It worked perfectly fine. And then I found out from Discover after that that it's actually exactly the same firmware, which is why you'll see that all the charge settings and everything are exactly the same. It just enables different parts of it when it's on that particular system, but the system itself is identical. So we can use those same values. You're then going to finish the wizard, and then you're going to be through here into the configuration settings. And there's just two values that you need to adjust. That's the max charge current value and the, I don't have a slide for it, and the size of the system. So you're going to put in X number of rack mount batteries, but then you're going to have to go in there and change the amp hour size of the system to match what you actually have, the number of Helios batteries that you have, so that it knows the size of the system. And then you're going to go and adjust this setting down here, which is max charge current as a percentage of battery capacity. And you want to set that to about 45. And that's going to adjust the charge current down to about 150 amps. And there's a good reason for that. So even though the maximum charge current on the specification sheet is 200 amps, it depends on how you measure it. So, and the Selectronic inverters have these massive capacitors in them and massive transformers, and they have, compared to something like a transformerless inverter like the Deye, they have a lot of DC ripple just because of the topology. And so there's peak current and there's, RMS. And so it depends on whether you which one you're measuring when you say 200 amps is your maximum. And what we found when we're doing the testing of the Helios with the Selectronic is, unlike other inverters, is that actually it's going to trip out if it's above 150 amps. It won't do it straight away, but if you run it for a half an hour at sort of 160, eventually it's going to trip. The guys from Selectronic also explained to me it's a difference between magnetic and thermal style breakers as well. I don't quite 100% understand how that affects the charge curve. But the short story is that it's 150 amps per Helios battery is what your maximum charge current is. Everything else, the wizard is set up perfectly fine, and you can just use those values. If there's any questions about that, just let me know. So before I move on, we're nearly at time. Just any questions about any of that stuff? Perhaps I'll just bring up the Selectronic wizard just to show you that one setting I didn't have a slide for. There's another issue with Selectronic, which I'm not actually at the bottom of, which is that there's two different versions of the SP-Link software available. So if you had 10 batteries, you'd set it to 1,500. But obviously, you're unlikely to have an inverter setup that's going to be capable of that. But there's two different versions of SP-Link. And it seems like managed batteries are a problem if you're using the newest version of it. So here we're just loading up our site. So we're going to go and we're going to do a new site. I'm just going to call that Helios. So the new version of SP-Link, I think it's something to do with the CSIP BISO, and it seems to create problems when you are setting up managed batteries. So if you're setting up a system and you're not getting all the options that you think you should do, then download the version 15.6, I think it is. There's two versions on their website, two most recent versions, and it's the 15 series is the one that you want. I need to find out from Selectronic what the story is with that actually. So you're just going to select to discover rack mount battery here, and then everything else is going to be as you normally would do it for whatever type of system you're doing with Selectronic. Go through all the way through. And then we'll be into our configuration settings. And so this is the setting I was talking about up here. So battery capacity. So that's going to be a 314 per Helios battery you've got. and then you're going to get over here to charger, and you're going to set that at about 45%, which is going to give you that sort of 140 amp value. Yes, so if you need version 16, if you want to use Select Live 2, can you go backwards with firmware versions for Selectronic? Yeah, I think you definitely can. I've done it. I forget whether I had to delete it or whether I just had to install the new one, install run the installer for the old one, and it just overwrote the newer one. But it's a bit of a pain. I don't think you can have both of them on your computer at once, but I'll ask them about that. I imagine, Martin, that you set it up, and then you set up the battery, and then you set up 16 to use Select Live 2. The old version is on the website. It's got, let's go to the website, shall we? I'm still sharing my screen. So you've got 16 available here, and then you've also got 15.4 available here. So if you don't require CSIP, I recommend 15.4. So yeah, I will actually, I'll check this, because I should have checked it before I did this, I'm sorry, and find out what the story is with that, and I'll send you all an email. So let's just progress with where we were. Pretty much done. So the rest of this is just about Link Cloud. So Link Cloud is the portal for monitoring Discover systems. You need to use a Link 2 if you're doing that. They only have an Ethernet port. They don't have Wi-Fi. So you'll need to have hardwired Ethernet to wherever you're installing it. And the advantage to this is that it gives you information on each battery. It gives you the state of charge, the voltage, the current, and the lifetime information on each battery instead of the average for the entire stack. So this is really useful if you've got a lot of batteries in a remote place. It connects over the internet. Nice little graphic showing that. And it has this nice system page. You can have multiple systems on your account, just like all these other platforms. You've got a history graph showing you what the general system has done. And then you can go through to the alarms page where you can set up alarms. This is really useful, actually. That works really well. You have to turn them all on. They don't come on as default, and you can add other people into the alarms as well. And then you go through to the battery list, and that shows you what's happening for each individual battery. And obviously the advantage of this, and it's the same with the rack mounts as well, is being able to see the state of charge of each battery when you're commissioning the system is really useful, because you can see the relative state of charge of them. So you can see if one of them's got an issue. And so if you've got a big site and it's a long way off, you're going to save a lot of time by knowing what the problem is before you get to site. It could be the difference between one site visit and numerous site visits. So for big sites with lots of batteries, I recommend it. And you can also download the detailed data logs as well. Question here from Martin. In practice, are Selectronic AC coupled with Fronius Gen 24 stable in off-grid situations, e.g. no high voltage shutdowns occur due to slow Gen 24 response and high load suddenly turned off? No, I mean, it's a pretty established system, I think. I've been told, and I haven't been able to verify this, but that the slow response is not as slow as you think it is. It's the reporting that you get back, which is slow, but actually ramps down quicker than what it reports back to you. So people say that the ABB responds quicker with a Selectronic system, but apparently it's actually just that the reporting is delayed rather than the actual response of the inverter. I haven't been able to verify that. all of these batteries have a bit of wiggle room in what they're asking to be charged up to. And so that allows for the inverter to be able to dump a little bit of power in there in that scenario that you're talking about. We recommend the dynamic current model for the Selectronic because it seems to respond better in that environment rather than the dynamic voltage, but it does work on the dynamic voltage as well. I hope that answers your question. If the temperature gets too low, it will shut down. Yes, I forget what the exact value is. I can bring it up here in the specs, but it's charging when it's cold is what the problem is, rather than discharging. So it can go quite low and continue to discharge, but it will not like being charged when it's cold. And that's a much more conservative value. I've got the spec just here. Where is it? Search for it. But there's a note in here which is slightly confusing. Here we go. This is it. No. But basically it's saying, here we go, charge operating temperature range. So the charge range is 4 degrees to 55 degrees, but the discharge range is -25 to 55. So you can continue to discharge it when it's cold down to -25, which is really low. You're not going to get anywhere near that, but it won't let you charge it when it's really cold. And then there's a note here saying that the heater will kick in, but it will only kick in when the Helios battery cells are between -25 and 5 degrees and either connected to a charging source or the battery state of charge is 50% or more, energy is diverted to the internal heater until the battery reaches 8 degrees. So the reason for that is that if it's, you can still discharge it. So it doesn't need to be past that 50% threshold. It won't bother doing it because it's assuming that it's going to heat up and then be able to charge later in the day, which is what that 50% value is. I hope that makes sense. Yeah, you're not going to get down to those values in mainland Australia, I don't think. The ambient temperature might get to it, but the internal cells thermal mass isn't going to get down to that. We haven't heard of any of them doing that at all. But you've got the heater in there if it does happen. So it's a non-issue, basically. Previous webinar, I did a section on setting up a remote GX screen, but what I wanted to show you, I'll just stop sharing my screen and go to the camera, is this box that I've created. So Discover are bringing out a combiner box, which will have Amphenol plugs on the bottom of it and have 5 125 amp breakers in it. And that will allow you to put 3 Helios batteries into that and then use the other 2 to go to either a larger inverter, or you could use a single pair of those to go to a smaller inverter. And so it's going to be Amphenol to Amphenol from the batteries into this combiner box. And it's going to be a really quick and easy installation. And they're 125 amp breakers because you're not going to need any more than that when you've got multiple batteries. That's going to be a month or 2 away. In the meantime, we've got these. So I've got all these bus bars made up. These bus bars are made of pure copper, nice and chunky. And the idea is that you'll load them into one of these enclosures and you'll have 3 circuit breakers and you put them in. They're designed to have one going one way and the other going the other way, and there's a spacer in between so they can't touch each other. And then you can take off your inverter cables from the two sides. You can also join them together to make a 6 if you want to, but it's really designed just to be used like this. So that is available now. If you've got any questions, we'll be putting up a data sheet on it shortly. Talk to your sales rep or just email me if you want to know more about them. And I've got like 15 pairs of these I need to get rid of before the other ones come. So hopefully people buy them and I don't get in trouble. Any more questions about that? We've gone over time. No? Okay, all good. So I will find out about that Selectronic issue with the software, and I'll send you all an email about that. And yeah, okay. We'll probably be putting this up on YouTube and sending out the slides as well. Okay, thanks for coming.